I'm back again, guys. Today we are in we will be dealing with what we call trigonometry. Today we'll be dealing with what we call trigonometry. Trig. They usually call it trig. So in this chapter we will be dealing with lots of things, but currently, or as for now, I just want us to pay some little attention to reduction formulas, because you need them the most. Okay, now this is more of the basic trigonometry. So let's say, okay, let's firstly draw our Cartesian plane. This is our Cartesian plane. This is our Cartesian plane. Here we have 0 degrees. Here we have 90 degrees. Here we have 180 degrees. Then here we have 270 degrees. Then we have 0 and also 360 degrees. We have 0, then we have 360. Okay, now so this is what you need to know. There are a few things that you need to know by heart here. In fact, you need to know trigonometry by heart. So we have this word or phrase, Socato. We have Socato. So this S here, this S, I am coming back here. Just that before I get here, you need to know this first. This S stands for sine. This O stands for opposite. Then this H stands for hypotenuse. Here on this was the definition of this. So now let's define that car. So this C stands for cosine. This A stands for adjacent. Then that H stands for hypotenuse, as always. Then now we are here now on DOA. So this T here stands for tan. This O stands for opposite. This A stands for adjacent. So this is the definition of Socato. So now this is the other thing that you need to know by heart. You need to know this OS T. Okay, it's ASTC. You need to know this by heart. You need to know this. This tells us that here on the first quadrant, quadrant 1, here is first quadrant, quadrant 2, quadrant 3, and here we have quadrant 4. So this tells that this A, let's write it here, A for all. This A tells us that all the trigonometric ratios in this quadrant, which is quadrant 1, are positive. Then now we have quadrant 2. We have quadrant 2 under S. So this S means sine on quadrant 2. This tells us that all trigonometric ratios on quadrant 1 are positive. Then this tells us that only sign on quadrant 2 is positive. So here we have sine positive. We have sine equals to positive. What about the other trigonometric ratios? We are going to have cos equals to negative and also tan equals to negative on quadrant 2, only on quadrant 2. So on quadrant 3, here is quadrant 3, so tan on quadrant 3 is positive. So here on quadrant 3, it's only tan that is positive. Sine is equals to negative and also cos is negative. Then on quadrant 4 now, quadrant 4, cos on quadrant 4 is positive. So it's only cos on quadrant 4 that is positive. So here cos is equals to positive, then tan is equals to negative, and also sine is equals to negative. So this is the basic. You are going to see again if where we go, where do we use these. These are very, very important basics. Okay, again we have what we call special angles. We have what we call special angles. The things that I am listing here are the things that you need to be familiar with, the things that you need to look at whenever seeing a trigonometric problem. Firstly, you check for Socato, you check for special angles, you check for the reduction what. So now the special angles, I'm just going to list the special angles, right? I'm just going to list them. Special angles are 0 degrees, 30 degrees, 60 degrees, 1 2 3, I'm sorry, 0 degrees, 30 degrees, 45 degrees, 60 degrees, and also 90 degrees. Special angles are 1 2 3 4 and 5. So we have 5 special angles. You need to know these special angles, why they are special. One day I'm going to tell you why they are special. Just that now I just wanna get to something else. I don't wanna make long videos and all. Okay, now so now let's go straight to reduction formulas. The best way to understand these, it's when working with problems. But before we go there, there's something that I just remembered. There's this thing that I just remembered. What are these? The correlations. We have what we call correlations. Correlations are only that you need to know. As for now, sine of angle theta and cos of angle theta, or any angle. So now what you need to know is that if maybe you were given, what you need to know is that sine of 90 degrees plus an angle theta is equals to So if we are given this and we are required to solve this, what you need to know is, what you need to do is to look back here on your, what do you call this, on your Cartesian plane. So 90 plus, here is your 90, here is your 90. So 90, from 90 going backwards, it's going to be 90 minus, right? From 90 to 0 it's 90 minus, but from 90 to 180 it's 90 plus. So angle theta must be somewhere here. So now that means your sign is positive, so this is equals to cos of theta. So how can we prove that? 90 minus 40 is 50. Okay, so now let's say we are required to find the value of what is sine of 50 degrees. So sine of 50 degrees is the same as sine of 90 degrees minus 40 degrees, and this is the same as cos of 40 degrees. Therefore sine of 50 degrees is equals to cos of 40 degrees. What I'm trying to show here is that sine and cos cooperate. They cooperate, they work together. So then let's quickly let's just leave the special angles. These are just the basics, remember. Let's go to what we call identities. Identities So here on identities, when you are this is just a matter of proving that the left hand side is equals to the right hand side. If so, let's prove what we already know. Let's prove sine squared of x. Now let's just write theta plus cos squared of theta is equals to 1. Given that, or required to prove that sine squared theta plus cos theta is equals to 1. So here it's our right angle triangle, then here it's our theta. Here we have x, here we have y, then here we have r. This is just an assumption. Remember, whenever proving, you gotta have some sort of an assumption. So if here is our sine of theta squared, right? So let's focus here now on theta. We said that sine, remember Socato, right? Socato, here is Socato. So sine it's equals to opposite over hypotenuse. So here it's our opposite sine, our opposite side. Here it's our hypotenuse side according to this angle. So here we have y over r all squared plus, then here we have cos. Remember, this is the left hand side, so left hand side is equals to this. So cos it's adjacent over hypotenuse, so here it's our adjacent and there it's our hypotenuse. So now adjacent is going to be x over r squared, right? Okay, cool. Now let's proceed. So this is going to be y squared plus x squared over r squared, and also here it's going to be like that. Okay, cool. The aim is to prove that all this is equals to +1. This is to prove that all this is equals to +1. Okay, cool. Then this is all equals to this times this, gonna give us this times that is going to give us it's gonna be r to the 4th. Oh yes. So it's going to be r to the 4th, right? And remember, then here we're going to have y. Oh, because so here this r and that r, we have r, that means we have the LCD, right? Because the denominator is the same, so let's just take r squared and put it there. So here we have y squared plus x squared, and remember the theorem of Pythagoras states that the square of the hypotenuse, which is r squared, is equals to the sum of the square of the two shorter sides, meaning r squared is equals to x squared plus y squared. Therefore, this y squared plus x squared is equals to r squared over r squared equals to 1. Therefore, the left hand side is equals to the right hand side, because the left hand side turns out that it's equals to 1 and also the right hand side equals to 1. Therefore, we have now proven our identity. What is it that is left? Okay, the compound angles. Now we're going to the compound. Now we're going to the compound. We're going to the compound angles. I'm not sure whether this is clear. I'm not sure if this is clear or what. So here on compound angles we have let's say we have cos of a plus b. This is just a formula. Cos of a plus b is equals to cos a plus cos of b. I'm sorry, there's no such. Cos of a plus b is equals to cos of a times by cos of b minus sine of a times sine of b. Then again we may have cos of a minus b, of which is going to be equals to cos of a times cos of b plus sine of a times sine of b. And notice that whenever it's cos, this sign cannot be the same as this one. If here you have a negative, then here you're going to have a positive. If here you have a positive, then here you are going to have a negative. Then here is the other case. This here is the other case. Sine of a plus b, it equals to sine of a times cos of b plus. Remember, if when dealing with sine, if here you have a positive sign, then even here you are going to have a positive sign, unlike when dealing with cosine. So here you're going to have cos of a times by sine of b. Then if you have sine of a minus b, then that will be equals to sine of a times cos of b minus cos of a times sine of b. So I'm not going to go to that to tan of a plus b. This is what I need you to know as for now. So what is it that is also left? Okay, now we need to go to what we call the double angles. But this all these are supposed to be there on your formula sheet. So double angles. So we have sine of 2 theta, it's equal, which is equals to 2 sine, which is equals to 2 sine theta times cos theta. So the double angle we are talking about is these two multiplied with that theta gives us a double angle. It's a double angle because we have twice theta now. So if we have cos of 2 theta, meaning a double angle of cos, then we may have about 3 equations. So cos of 2 theta is equals to as cos squared of theta minus sine squared of theta. It's also equals to 1 minus 2 sine squared of theta, also equals to 2 cos squared theta minus 1. I'm not going to prove if how did we get here, how did we get there. I'm not going to prove that. So this is all you needed to know about trigonometry at your high school level. This is all you needed to know about trigonometry. Yes, this is the real basic of trigonometry. I think now we should solve problems on the following video. Thank you. Please do not forget to subscribe on my channel.